Hello everyone. Today we discussed about the new chapter, continuity and differentiability. Continuity, it is a one word, and differentiability is another word. This is a very important chapter. Why? Because it will carry the 20 marks in PU board. Observe here continuity. Continuity. First exercise total will discuss about the continuity, and remaining exercises differentiability will start. So first we will see about the continuity. Continuity. What is a continuity? What is continuity? In general, we can see by the graph, we will see one function is there, one curve is there, curve it is continuous curve. If any gaps is there, it is not a continuous. It is not a continuous. It is discontinuous. Next, one more we can see here. Here you can see this is a discontinuous, continuous. By the graph you can see this is the continuous or not. Next, one example we will see. F of x is a function. F of x is a function. It defined as x is not equal to 0. F of x value is 1. X is equal to 0. F of x value is 2. So draw the graph of this function. If we draw the graph of this function, x is equal to 0. F of x value is 2. For example, I am taking this is a 2 and this is 1. Now, greater than 0. Greater than 0 means it is not equal to 0. Like this one value is there, next one more value is there. Here you can see this is a gap, continuous not there. If you draw a line, you have to remove the pen or pencil compulsory here. If you draw the curve continuously means it is a continuous curve. If you remove the hand from your book is that means that is a discontinuous. So by the graph you can see this one. But every function we can't draw the graph, and that is a very lengthy process. So that that problem overcoming purpose only will use the continuity concept. In that limit concept we will use. So we will see that next. Next definition. A function, continuous definition. A function is continuous at x is equal to p. P is a one number, real number. If the function is defined as x is equal to p, when it is continuous at x is equal to p, first of all, defined at x is equal to p. That means it is exists at p. And if the value of the function at x is equal to p, at x is equal to p, what is the value of function? That is equal to limit of a function at x is equal to p. This is a theoretical definition. At one particular point p, f is continuous. When it will be continuous? First of all, it will be exist. Next, the value of the function at that point is equal to the limit of a function at that point, m point. This is what we will write in mathematical limit concept. Limit x tends to c, f of x is equal to f of c. This condition satisfies means it is a continuous function. Or this one. Limit concept is the left hand limit and right hand limit. Limit x tends to c minus f of x is equal to limit x tends to c plus f of x is equal to f of c. This is only we can write as a LHS is equal to RHS is equal to f of c. F of c. Left hand limit is equal to right hand limit. Then only it will exist. Equal to f of c. And next, if f is not continuous at c, at one particular point f is not continuous, then we can say that f is discontinuous. F is discontinuous, and P, the point P is called discontinuity, point of discontinuity. That point P is called point of discontinuity. Next, in problems we can use sometimes this definition and this one also. This one or this one. So, how you have to remember that? One easy shortcut method is there. Equal, not equal, getting in question. That time you have to use this formula. Next, less than or equal to, greater than or equal to, less than, greater than, like this symbol figure. Second we have to follow. It is a very easy to understanding purpose. I am writing here. Equal, not equal is this concept too. If less than, greater than or equal like that is we have to use LHL is equal to RHL is equal to f of p. Next definition is a real function f is said to be continuous function it is continuous at every point. At every point continuous is that is a continuous function. Which point that is domain of a function f mapping from natural number to natural number and base. When that function f is continuous means every point of domain, every natural number here, every natural number, it is continuous means that function is continuous function. So these are the three very important definitions here, and this formula and this formula will use in next exercise problem. We'll see the next example problem. Next, example 1. Check the continuity of a function f is given by f of x is equal to function 2x plus 3 at x is equal to 1. At x is equal to 1, we have to check it is continuous or not. We have two formulas. I told already, I mentioned here. Either this one or this one we can use here. So first I use equal, not equal is the first concept I use. Less than or equal to, greater than or equal to the second. LHL is equal to RHL is equal to that concept I use. Here, only single function is there. Direct I'll find first f of 1. F of 1. X is equal to 1. So f of 1 is equal to 2 into 1 plus 3. That is equal to 5. Next, limit I'll find. Limit x tends to c. C is nothing but here 1. So f of x. Limit x tends to 1. What is the f of x value? 2x plus 3. 2 into x tends to 1 means approximately equal to 1. That is nothing but 0.999999. Otherwise 1.00001 also. So approximate value we can take as a 1 only plus 3. That is equal to 5. Therefore, limit x tends to 1, f of x is equal to f of 1. First condition satisfied. Therefore, f of x is continuous at x is equal to 1. Next, example 2. Examine whether the function f is given by f of x is equal to x square is continuous at x is equal to 0. Continuous at x is equal to 0. For that purpose, we have to find f of 0 first. F of 0. 0 square is 0 only. Next, limit x tends to 0. Limit x tends to 0. F of x. Limit x tends to 0. F of x. Limit x tends to 0. F of x value is x square. So tends to 0 means x value is 0 square. Both are equal. Limit x tends to 0, f of x is equal to f of 0. Therefore, f of x is continuous. I am writing now on what? CTS. That is nothing but continuous at x is equal to 0. Next, problem number 3. Discuss the continuity of a function f is given by f of x is equal to mod x at x is equal to 0 is also right. First I will take the mod function. Mod function we can write as a two ways. We can write as a two ways, that is plus x and minus x. If x is greater than or equal to 0, mod x value will be x. If x is less than 0, mod x value is minus x will be. So now less than greater than symbol is there, so I will use the second property, second formula. LHL I will find one. What is the LHL here? LHL purpose limit x tends to 0. Showing purpose will write left hand limit, showing purpose negative will write 0 minus f of x limit x tends to 0 minus f of x. What is the 0 minus means? Less than 0. Less than 0 means function value is minus x. 0 minus less than 0. So that's why minus x we have to take. Substitute here minus 0. That is nothing but 0. Next, RHL, right hand limit x tends to 0 plus f of x is equal to limit x tends to 0 plus. It is a very small, more than 0, greater than 0. So that's why function value is x. Here you have to substitute 0, answer will be 0. Next, let 0, f of 0 equal to 0. Equal to 0 means x you have to write. What is the x value here? 0. So LHL equal to RHL equal to f of 0. F of 0. Therefore, f of x is continuous at x is equal to 0. Next, show that this function is discontinuous at x is equal to 0. Function what here? 2 is there, but here question you observe equal, not equal is there. So first concept only I use here. Limit x tends to, point is 0, x tends to 0, f of x. Limit x tends to 0. What is the f of x value? Tends to 0 means not equal to 0, approximately equal to 0, not equal to 0. So that's why I will write x cube plus 3. Approximate equal to 0 means what is that? 0.0001, otherwise minus 0.99999. So that purpose only I am making here approximate value. So 0 I am taking. 0 plus 3 is equal to 3. Next, f of 0. We can find first also. This problem will be f of 1 first we find. This problem second. No problem. You can rearrange this. F of 0 is equal to 0 means answer is 1. Limit x tends to 0. F of x is not equal to f of 0. Therefore, f of f is not continuous at x is equal to 0. Not continuous means what here? Discontinuous. Not continuous means discontinuous. What is the point of discontinuity? Point of discontinuity is 0. Possibility. Algebra of continuous functions. Suppose f and g are two real functions. Continuous at a real number 2. F and g are two real functions, continuous at a real number c. So, algebra is nothing but addition, subtraction, multiplication, division. f plus g is continuous at x is equal to 3, f minus g is continuous at x is equal to 3, product also continuous at x is equal to 3, f by g, quotient rule, that is on the quotient will call, f by g is continuous at x is equal to c, but g of c compulsory not equal to 0. Why? Because if g of c is 0, this function only not defined. Compulsory first function defined, then it is continuous. So function does not define. So that purpose we are giving here condition g of c is not equal to 0. Next, some important points is that will every polynomial function is polynomial function. Polynomials we know already, x square plus 3, ax power n plus total, continuous polynomial total. Function is continuous. Every rational function is, rational function means p of x by q of x. Q of x stands for not equal to 0. P of x and q of x are two polynomials. Like that condition satisfied means that is a rational function. That rational function also continuous function. Next, theorem number 2. Suppose f and g are real valued functions. F and g are real valued functions. F circle g is composition of functions. Composition function means what? Two or more functions including in one function is defined at C. First of all, it is defined. G is continuous at C. G is continuous at C and f is continuous at g of C. G is continuous at C. F is continuous at g of C. So G circle F is continuous at C. One example I am taking here. Sine of x square. Sine of x square. Sine is the one function. X square is the one function. Combined of two functions is there. So this is the call. This type is called composite function. X square is continuous function. Sine is a continuous function. So sine of x square is continuous function. That only this is the theorem number 2. Next, sine value, cosine value, tan value, trigonometric value. Trigonometric values are continuous functions. Trigonometric ratios are continuous functions. These are the basic important points we will use in an exercise. So next we will see the exercise problem. Next exercise problem number 5.1. First problem. Prove that function f of x is equal to 5x minus 3. Function is f of x is equal to 5x minus 3 is continuous at x is equal to 0, x equal to minus 3 and x equal to 5. That's 3 points we have to check. First and second. At x is equal to 0. At x is equal to 0. We have the formula. First property I use. Limit x tends to c. F of x is equal to f of c. That's concept purpose. First, f of 0. F of 0. X place you have to substitute 0. Minus 3. Next, limit I find. Limit x tends to 0. F of x is equal to limit x tends to 0. X tends to 0. What is the f of x value? F of x value is 5x minus 3. Approximate value, that is 0. So directly we can take as a 0. Minus 3. Therefore, limit x tends to 0. F of x is equal to f of 0. Therefore, condition satisfied, definition satisfied. F is continuous at x is equal to 0. Next, at x is equal to minus 3 is how to take. That x is equal to minus 3. So first you have to find f of minus 3. F of minus 3. X plus what we have to substitute? Minus 3. And minus 3 is the minus 3. So minus 15 minus 3, that is minus 18. Next, limit you have to find at minus 3. Limit at minus 3. Limit x tends to minus 3. F of x is 5x minus 3. 5 of tends to minus 3, that is nothing but automatically will take minus 3, minus 3. Just you see this only same you get minus 18. Therefore, limit x tends to minus 3. F of x is equal to f of minus 3. Therefore, f is continuous at x is equal to minus 3. F is continuous at x is equal to minus 3. One more also then. At x is equal to 5 is how to check now. At x is equal to 5. First you have to find f of 5. F of 5. That is, what is the function? 5 into x. X means 5 minus 3. 25 minus 3. That is equal to 22. Next, limit x tends to 5. Limit x tends to 5. F of x. Limit x tends to 5. F of x is 5x minus 3. 5 into 5 minus 3, that is nothing but 22. Therefore, limit x tends to 5. F of x is equal to f of 5. F of 5. Therefore, f is continuous at x is equal to 5. Next, problem number 2. Problem number 2 is examine the continuity of the function f of x is equal to 2x square minus 1 at 2x square minus 1 at x is equal to 3. Examine the function f of x is equal to 2x square minus 1 at x is equal to 3. So solution here at x is equal to 3 is how to find. F of 3 substitute next 2 into 3 square minus 1, 2 into 9 minus 1, that is 18 minus 1, 17. Next, limit you have to find. Limit x tends to 3. F of x is equal to limit x tends to 3. 2x square minus 1. 2 into x tends to 3. So 3 square minus 1. 3 square is 9. 9 to the 18. 18 minus 1 is 17. Therefore, limit x tends to 3. F of x is equal to f of 3. F is continuous at x is equal to 3. F is continuous at x is equal to 3. Problem number 3. Examine the following functions for continuity. These 4 questions continuous are not. Just to see solution. F of x is polynomial. F of x is x minus 5 is a polynomial. Every polynomial is a continuous function. Therefore, f of x is continuous. F of x is continuous. Why? Because x minus 5 is a polynomial. No point we wrote it. Next, f of x is equal to 1 by x minus y. F of x is equal to 1 by x minus y. This is in the form of f of x is equal to 1 by x minus 5 is rational function. Rational function. Every rational function is continuous. Therefore, f of x is continuous. F of x is continuous. Next, this problem you can see. F of x is equal to x square minus 25. We can write this as x square minus y square by x plus 5. So, a square minus b square formula is a minus b into a plus b divided by x plus 5. X plus 5 cancel is equal to x minus 5 is polynomial. Therefore, f of x is continuous. Every polynomial function is continuous. Next, problem number D in the column. Mod function is there. When mod function is there, compulsory how to make here. You can write as a x minus 5 positive is x is greater than or equal to 5, x is greater than or equal to 5, minus half x minus 5 is x is less than 5. X is less than 5. Simply here, mod function, mod x is equal to x and minus x. X is greater than or equal to 0, x is less than or equal to 0. Here nothing is there, is less than 0. Here 5 is there, so we have to write number 5. So now we have to check that less than greater than symbol is there, LHL, RHL we have to find. LHL. F of x is equal to limit x tends to 5 minus less than 5, constant value is minus of x minus 5. So now we substitute here value minus of x value, x tends to 5 minus. Small lesser value is less, so we can write 5 only. 5 minus 5 is 0. Next, RHL, limit x tends to 5 plus, limit x tends to 5 plus, f of x is equal to limit x tends to 5 plus greater than 0, greater than 5. So, x minus 5 is out of x, greater than 5. This is equal to 5 minus 5 is 0. LHL completed, RHL completed, f of 5. F of 5 equal to 5. Equal 5 is x minus 5. X plus we have to substitute 5. 5 minus 5 is 0. LHL is equal to RHL is equal to f of 5. Therefore, f of x is continuous at x is equal to 5 and both are polynomials only. So, f of x is continuous function. Why we are writing this one means that at x is equal to particular point 5 we find the continuous x is equal to 5. The remaining value greater than 5, polynomial only, less than 5, polynomial only. So we can find, we can conclude that both polynomials is a continuous function. Only special case 5 is there, because 5 is substituted here. F of x is continuous at x is equal to 5. Next, problem number 4. Prove that the function f of x is equal to x power n is continuous at x is equal to n. N is positive integer. Directed f of n first I'll find f of n. F of n means n power n. Next, limit I find limit x tends to n. F of x is equal to limit x tends to n. F of x value x power n. x value is n into n, that is nothing but small lesser value of n, small more than n. So no problem, we have to take n only. Therefore, limit x tends to n, f of x is equal to f of n. Therefore, f of x is continuous. F of c. Next, problem number 5. If the function f defined by f of x is equal to x, if x is less than or equal to 1, f of x is equal to 5, if x is greater than 1, continuous at x is equal to 0, at x is equal to 1, x is equal to 2. 3 places we have to check the continuity. First I'll take x is equal to 0. At x is equal to 0. We can observe here 0. 0 means less than 1. 0 minus also less than 1. 0 plus very small value plus, that is means 0.00001. That is also less than 1. LHL, RHL we can find, otherwise direct limit also we can find. So I am using here LHL method. LHL. First, f of 0 I will find. F of 0. F of 0 means equal 0. Equal 0 is there, that is less than 1. Less than 1 answer is x. X value is here 0. Limit x tends to 0 minus f of x. Limit x tends to 0 minus. It is less than 1. So x value is, f of x value is x. Now we have to substitute 0 minus. 0 minus is nothing but approximate value 0. Next, RHL. Limit x tends to 0 plus f of x is equal to limit x tends to 0 plus. It is greater than 0. Greater than 0 means 0.0001. Very near value. That is also compulsory less than 1. So f of x value will become x. 0 plus is very small value 0. Therefore, LHL is equal to RHL is equal to f of 0. Therefore, f of x is continuous at x is equal to 0. X is equal to 0 completed. Next, x is equal to 1. At x is equal to 1, we have to substitute. At x is equal to 1. So first, f of 1 I will substitute. F of 1 equal to 1. Equal 1 means function value is x. X how much here? X is 1. So answer is 1. Next, LHL. Limit x tends to 1 minus f of x is equal to limit x tends to 1 minus. 1 minus means less than 1. Less than 1 is function is x. So approximate value, so we can substitute 1. Next, RHL. Limit x tends to 1 plus f of x. 1 plus f of x. So 1 plus greater than 1. Greater than 1 is the function value is constant 5. Limit of a constant number is that constant number only. Therefore, LHL is not equal to RHL. LHL is not equal to RHL. F of x is not continuous at x is equal to 1, or f of x is discontinuous at x is equal to 1. Next, at x is equal to 2 is also check. X is equal to 2. I told starting only LHL method is applied, normal method, direct limit also apply. Why? Because here only single function limit. 2 is there here actually, but it is more than 1. 2 minus also more than 1, 2 plus also more than 1. So function will become 5. But we'll write LHL RHL method only, f of 2. equal to 2, that is greater than 1. Greater than 1 is their function value is 5. Next, LHL, less and limit x tends to 2 minus. 2 minus means what is the value of 2 minus 1.9999, so on it will get. So that's why it is greater than 1. 1.999 is compulsory greater than 1. So constant value will become 5. Limit of the function value is, constant value is 5. RHL, limit x tends to 2 plus f of x is equal to limit x tends to 2 plus f of x, 2 plus 2.0001. It is greater than 1. Greater than 1 means function value is 5. Function value is 5. So answer will become 5. Why? Because limit of the constant function is constant. Therefore, LHL is equal to RHL, that is equal to f of 2. Therefore, function f of x function is continuous at x is equal to 2. So it is continuous at x is equal to 0, continuous at x is equal to 2, but it is discontinuous at x is equal to 1. So that function is not continuous function. One place it is discontinuity here, so it is not a continuous function, but separate points it will be continuous.